now that we've talked about the idea of isotopes, we can introduce the idea of average atomic mass, which is something that we'll be using a lot in this class. So we'll talk more about the periodic table in just a little bit, but before we get there, the numbers on the periodic table, they're the few important numbers there. So you'll see something like these boxes that represent. So we'll look at carbon. You see the symbol in the middle that represents the element that we're talking about. On the top, you'll have the atomic number. So carbon has 6 protons in it, so it has an atomic number of 6. And then underneath it, you'll have a number that looks like this, 12.011. And this number is what we call the average atomic mass. Now, why do we need this whole idea of average atomic mass? So what this tells us is how much does the average carbon atom weigh in atomic mass units. We'll see that this also corresponds to a different unit that we call grams per mole, but we'll get there. We're not there yet. But we can just think about this as the mass of a single carbon atom. Now, carbon, if we want to write its nuclide symbol, the most common isotope of carbon is carbon-12. And carbon-12 by itself has a mass of exactly 12 AMU. This is actually how AMUs are defined. They're relative to this carbon-12 isotope. But that does not match up with this value that we have here, right? This 12.011. If you look this up on any periodic table, you will not see that it's never exactly 12. And so the reason for this is that there are other isotopes of carbon that naturally occur. So other isotopes of carbon. So the other really common one, well, relatively speaking, is carbon-13, which has a mass of about 13 AMU. Not exactly 13. Unlike carbon-12, it's not defined such that it's exactly 12. But there's a little bit of carbon-13. It's something like 1%, if I remember right. In any sample that you get from most places, you'll have this ratio of about 1% carbon-13, about 99% carbon-12. There's even some other isotopes of carbon, but they're even less common than carbon-13. You can have carbon-14, which happens to be radioactive, so it doesn't last very long. And maybe there's a few other ones as well, but mostly it's these carbon-12 and carbon-13 that matter. And so the fact that the atomic mass that's represented on the periodic table is slightly higher than 12 is due to the fact that we have this 1% carbon-13 that's present in natural abundance. And so what we do to get these average atomic mass numbers that are on the periodic table is our mass, for example, of carbon, we would take, and I'm just going to use rough numbers here. This is not exact, but you would need to get the exact numbers to get the values on the periodic table. We would take 99% times 12 AMU plus 1% times 13 AMU. And then that would give you your average atomic mass. And this is repeated for all the other elements on the periodic table. Now, these values these are known as the natural abundances. And you have to figure that out from measuring many samples all across the world. And these are the natural abundances on Earth. These actually can vary a little bit from place to place even, and depending on where the carbon has come from. Whether it's from burning fossil fuels or whether it's from burning biomass or things like that. But we take an average over all the samples that we've been able to measure on Earth and use that as our benchmark. And so for any given symbol, any given atom that you look at on the periodic table, you'll see one of these average atomic masses, and you'll see that none of them are exactly equal to one thing. So in some cases there are multiple isotopes that are about the same abundance, and you get very different looking average atomic masses for those. But that's where these numbers are coming from. So in the next section, we'll talk more about the periodic table.